Hello, hi. Good evening, all of you. So, gravitation is the second video, the gravitational field strength E. సో ఈ టాపిక్ ఇది కూడా చాలా ఇంపార్టెంట్ అండ్ జేఈ అండ్ నీట్ పాయింట్ ఆఫ్ వ్యూలో. సో మనకి సిరీస్ ఆఫ్ వీడియోస్ వస్తాయి కంప్లీట్గా జేఈ అండ్ నీట్ ఎవరైతే సీరియస్ ఆస్పిరెంట్స్ ఉన్నారో వాళ్ళు ఫాలో అవ్వండి. అండ్ ఐఎమ్ షూర్ డెఫినెట్లీ దిస్ కైండ్ ఆఫ్ క్వశ్చన్స్ విల్ ఆస్క్ ఇన్ ఎగ్జామినేషన్. సో ఆల్రెడీ ప్రీవియస్గా ఈ మోడల్ క్వశ్చన్ చాలా ఉన్నాయి అండ్ ఇంకా కూడా చాలా క్వశ్చన్స్ వస్తూనే ఉన్నాయి ఇలాంటి క్వశ్చన్స్. సో ఈజీగా స్కోర్ చేయడము ఎట్లా అంటే టాపిక్ ఐడియా ఉండాలి, కాన్సెప్ట్ ఐడియా ఉండాలి, దాన్ని హోల్డ్ చేయాలంటే మినిమం బేసిక్స్ ఉండాలి. దాంతో మనం ఎంత పెద్ద కాన్సెప్ట్ అయినా హ్యాండిల్ చేయొచ్చు. రైటా? ఓకే, సో చూద్దాం. గ్రావిటేషనల్ ఫీల్డ్ స్ట్రెంగ్త్ అన్నాడు. సో గ్రావిటేషనల్ ఫీల్డ్ స్ట్రెంగ్త్ విచ్ ఈస్ డినోటెడ్ బై E. Now here I am taking, now E is equals to gravitational field strength, E is equals to the force experienced per unit mass. Force experienced per unit mass, if F by m, force per unit mass, is also known as gravitational field strength or gravitational field intensity. Now we have some units for it, right? Now units are force, newtons, and meter. Sorry, newton per mass. Mass means kg. Newton per kg. Right. So here, so in this topic, so I am taking for example, I am taking two different masses, right? So here I am taking an example. Here two masses. So m1 is a mass and m2 is another mass. These two masses, here I am taking at a point P. So here point P. So m1 is at a distance of r1 from P and m2 is at a distance r2 from P. Right? Now these two masses are acting at a point. Now the gravitational field intensity at this point, so here I am taking, so gravitational field intensity at this point is here E1 and here it is E2. Now even how can we written the E1? Now E1 is writing, I am here, so E1 is equals to, so G m1 by r1 square, m1 by r1 square, and here E2, so similarly E2 also written as E2 is equals to G m2 by r2 square, So E1 and E2, so E1, this is a vector quantity and this is a vector quantity. Now we have some vector sum. So vector sum which is taken as E is equals to E1, E bar is equals to E1 bar plus E2 bar, E1 bar plus E2 bar. This is known as principle of superposition. This is known as principle of superposition of vectors. Principle of superposition of vectors. E1 is a vector and E2 is another vector. Now the total or net gravitational field intensity, E bar is equals to E1 sum of the E1 plus E2. This is known as the principle of superposition. Right? So I am taking another example like this. Are you understood this, right? Now the second example is yes. So I am taking second example 2. So here let us consider a triangle. So here, so this is the triangle, equilateral triangle. So equilateral triangle of side length A, and three masses are placed at the identical masses are placed at the vertices of the triangle. 3 masses. Now here at the center, exactly at the center here, say some point X, and now on the line joining of these two masses at some point here it is a Y. Now find the gravitational field intensity at X and the Y points. So find gravitational field strength at X comma Y is. సో ఇప్పుడు ఎక్స్ దగ్గర ఈ వై దగ్గర గ్రావిటేషన్ ఫీల్డ్ ఎంత ఉందో ఫైండ్ అవుట్ చేయండి, రైటా? ఓకే, నా ఎక్స్ దగ్గర గ్రావిటేషన్ ఫీల్డ్ ఫైండ్ అవుట్ చేయాలంటే సో చూడండి, సో హియర్ ది one gravitational field is acting in towards M, so this is say some E, and here also some gravitational field acting like this towards this M, and here also some gravitational field acting here. Now the net gravitational field strength at this point is how much? Can you get this? 0. Yes, correct. So here 0 because of 3. So here also gravitational field intensity E, here also gravitational field intensity E. So at this point gravitational field intensity 0 because ఎందుకు 0 ఒకసారి ఇక్కడ చేస్తుంటుంది. So this is the point X. So this is X, right? So here this gravitational field intensity resolved into two components. One component is in horizontal direction, this is so E. So here it makes an angle, how much here it makes an angle? Theta 120, 120, 120. How much angle? 120 degrees, right? So here just I am taking E cos theta, and here in the vertical direction E sin theta. So this E is resolved into two components. This is E, of course, and here also this is also E, which is also resolved into two components. So this E also resolved into two components. One is like this. So this is E cos theta, and again downward E sin theta. Now this E cos theta both are in opposite, hence they are cancelled. And we have only, so E sin theta plus E sin theta, how much? So this is 2E sin theta. So 2E sin theta. Actually, now you can see here, so here it makes an angle between them is how much angle here? So it is angle is 60 degrees, equilateral triangle 60 degrees. So exactly which divides into 30. So here sin 30 which is equals to 1/2. Now 2E sin 30, here theta is taken as 30, sin 30 degrees. Now 2E, so sin 30 1/2. Now 2 gets cancelled, then we have E. So only in this direction we have E, and E both are in opposite direction and they are cancelled. So therefore no gravitational field strength at that point here. No gravitational field strength at this point. Have you understood this? Right? Okay. Right. So at the point X, Ex is equals to 0. Ex is equal to 0. Now we want to find at Y. So here you can see here at this point, so due to this mass, the gravitational field here it is how much? So here it is E, and same amount of gravitational field due to this mass E. So both are in opposite direction, hence both are gets cancelled. So here also E and both are gets cancelled. Now we have only gravitational field due to this mass only. So like this. So this is the equilateral triangle, and here masses are gets gravitational field intensity gets cancelled, in horizontal gets cancelled. We have only the vertical gravitational field like this. So this is only. So we know the length, the total length is A. Now it is A by 2, and here it is also A. Now here it makes an angle 60. Now what is this length? So this is taken as R. Now what is the value of R? Now R is taken as sin 30 opposite by sin 60 opposite by adjacent. So here I am taking sin 60, that is equals to opposite R by hypotenuse A. Sin 60 root 3 by 2 is equals to R by A. Now therefore R is equals to A root 3 by 2. Now this is the value is A root 3 by 2. This is the value of R. Now at this point, so this point the gravitational field strength Ey, it is taken as, so Ey is equals to G into M by R square. So actually R square is, I am writing here R square, but R square means how much? So this is R square. R square means how much? So this is the value of R. Then we have Ey is equals to G M by A root 3 by 2 whole square. Now this is Ey is equals to, now A square into 3, so 4. So how much? So G M by A square into 3 by 4, and 4 పైకి వస్తుంది అంటే అప్పుడు ఎంత వస్తుంది 4gm by 3a square. This is the gravitational field intensity at the point here. Now at the centroid is how much? At the centroid is 0. At the centroid is 0, and then finally what we get here, Ey is equals to 4gm by 3a square. This is the center of the side, one of the side. Now at the point x is 0, at the point y is, we have 4gm by 3a square. So this is the at 2 points x at x and y. This is about the gravitational field strength. Gravitational field strength. ఓకే, సో ఇలాంటి క్వశ్చన్స్ ఒక్కసారి నేర్చుకుంటే చాలు. ఈ వాల్యూస్ ఏమైనా చేంజ్ చేసినా కూడా మనం ఈజీగా చేయొచ్చు, రైట్? నోట్ దిస్ పాయింట్. ఓకే, రబ్ చేస్తున్నాం. Next to null point. Null point. So null means 0. Null point means so between the two masses, the gravitational field intensity will be 0 between two masses. Between the two masses or away from the two masses, right? So here I am considering, null point means what? Gravitational field intensity is 0 at a point. At a point, E0 at a point is known as null point. Now here I am taking, so two masses, m and 4m. M and 4m. Now the line joining between them is some, they are separated by some distance r. Now anywhere between the two masses, anywhere. So here I am taking not exactly at the center, because of they are not equal masses, are not same masses. So null point which is near to the m1, not exactly center, because of they are not same masses. So here the electric field the gravitational field intensity or gravitational field strength will be 0. Now we don't know the distance here, so this is the distance from M, which is taken as some x, and the total distance is r, of course, x. What is the remaining distance? The remaining distance is taken as r minus x. Now at this point, the gravitational field due to M is E1, and at this point, so gravitational field due to 4m, this is E2. So E1 and E2 are at this point. At this point there is no gravitational field, but we have E1 from M1 and E2 from M2 of distance, of different distances. You can see here, right? Now E gap and the distance of x undi kada, ee x distance unnappudu m mass x distance unnappudu E1 enta ostadi? So E1 is equals to gm by x square. Say equation 1. So ikkada idi enta ostado cheptara? E2 is equals to gm. M means how much here? 4m by how much of distance here? R minus x whole square is the equation 2. Now E1 and E2 both are same. Ekkada E1 and E2 both are same at the null point. So here ఇది ఎంత ఉంటదో gravitational field intensity ఇటువైపు కూడా అంతే ఉంటది. Both are same. So both are same అనుకున్నప్పుడు E1 is equal to E2 అయితే ఈ రెండు ఈక్వల్ చేయండి. So therefore అప్పుడు ఎంత? So gm by x square is equals to 4gm by r minus x whole square. Now gm gets cancelled. Now so here r minus x whole square by x square is equals to 4, and this is written as r minus x by x whole square is equals to 4. Now r minus x by x is equals to square of the root 4. Root 4 means how much? 2. Now r by x minus 1. So r by x, now I can write like this. So r minus x by x is equals to 2 root 4 2. Now r minus x is equals to 2x. Now r is equals to 3x. R is equal to 3x. Therefore x is equals to r by 3. Now x is equal to r by 3. That means the distance of null point. X is the distance of null point from small m. That is equals to r by 3. Now the remaining part is the distance of null point from 4m. That is r minus x. Now we get here x value. So x is equal to r by 3. Okay. So itla manam ఏ వాల్యూస్ అని ఇవ్వండి, ఇట్లా సింపుల్ గా చేసుకుంటా ఇప్పుడు. ఓకే, ప్లీజ్ మేక్ నోట్ దిస్. yes. So example number 3, right? Gravitational field strength at the center for semicircular ring E at center. So semicircular ring E at center. So I am considering a semicircle. So this is the semicircle, right? So this is the semicircle. Yeah. So this is the center. Now we need to find the E at the center here. Now the radius is r, of course. So this is the radius. Now the radius is r. Now gravitational field intensity at the center is E. We need to find that. And here, so this is the semicircular ring. It have the mass m. It have the mass m. Now linear density rho. Linear density is rho. Yes. So here this Newton's law of gravitation is applicable for the point masses, but here the distribution of mass. So therefore it is cut into small pieces like dm. So here I am considering small mass dm. So here it is dm. So this is the ring. Small mass dm. So this is the small mass dm. Now, yeah, so here angle is small angle d theta. Small angle d theta. Now the total angle is taken as theta, of course. So this is theta, but here I am taking here it is d theta for the small mass dm. So dm means this is the small mass dm. Now this dm means point mass, small mass. So this gravitational field intensity. So gravitational field intensity resolved into two components. One is the horizontal component, so E cos theta, and other one is E sin theta. So like this. So here it one is E cos theta, and up one E sin theta. But here also you can take dm here. So here also, for example, I am taking dm, small mass here. So dm. So this is the E value, and E is resolved into two components, E cos theta and E sin theta. So E cos theta, E sin theta. So here also E cos theta. If I am taking mass here small n, so this is the small n, right? So this is E. Now E is resolved into two components, so E cos theta, E sin theta. So every point we can take dm here. So E cos theta, E sin theta. Here also, so E cos theta, E sin theta. So E cos theta, E sin theta. E cos theta, E sin theta. Here also. So E cos theta gets cancelled. All the E cos theta gets cancelled. We have only sin component. We have only sin component. Because of we can take here along this line, E is resolved into two components, E cos theta, E sin theta. So here also E sin theta, E cos theta. So we can take here, so E sin theta, E cos theta. So all E cos thetas, either side, E cos theta gets cancelled. We have only E sin theta. We have only E sin theta. So therefore, I am writing here, right? So therefore I am writing here. So at the center, the radius is R. So I am considering only, so here small mass. So this is small mass. This is the radius. Okay. So here angle is d theta. Angle is d theta. Right. Okay. Now angle is equal to arc by radius. So this is the arc. Angle is equals to angle means here d theta, angle is equals to arc means this line, arc means some x by radius. Now x is equals to r into d theta. Now this is the value, x is r d theta, so it is E value. So this value is r d theta, right? So here the gravitational field intensity for this mass is written as dm, dE is equals to g into dm by r square. So dE, small gravitational field strength, which is equals to g into dm. So this is the mass dm. So this is dm. Now dm by r square. Now here dE. So dE means E resolved into two components. So this is the E. dE is resolved into two components, dE cos theta, dE sin theta. And here also dE sin theta, dE cos theta. So gets cancelled. We have only sin theta components, right? So therefore dE is taken as, no, dE is taken as dE sin theta. dE is taken as dE sin theta. So we have dE sin theta. Now the dE sin theta, this is equals to dE. We know the dE value. So this is equals to dE is equals to dE sin theta. Now dE means G dm by r square into sin theta. So dE is, finally we have dE is equal to dE sin theta. Now dE is equals to dE into, so dE into sin theta. Right, now integrating on both sides. Integrating on both sides. Now what we have? So integral dE is equals to, so G by r square integral dm sin theta. We cannot integral here dm, so sin theta. So dm must be converted into angles in terms of theta, right? Now say this is equation 1, but here we have mass per unit length. So mass is m per unit length. Unit length means so circumference. The circumference means this is a semicircle. Semicircle means mass per semicircle pi r only. For the circle we can take 2 pi r, but it is a semi, we can take pi r only. And this is equals to mass, small mass per small length. Small length means this is the small length. Small mass per small length. Small length is r d theta. R into d theta. Mass per unit length. Small mass per small unit length. Both are same, which is same everywhere on the ring. Mass per unit length is same per everywhere in the on the ring. So therefore mass per unit length, this is equal to small mass per small length. So this is the small length. Small length is equal to r d theta. I am writing here. Now r gets cancelled. Now what we have? So dm. Therefore dm is equals to, so m d theta by pi. M d theta by pi. So this dm value substitute here. So therefore integral dE is equals to G by r square m by pi into sin theta d theta integral. So dm m d theta by pi. Now here integral limits are taken from, but here, so this is the e. Now the angle is here 0. Now 0, so 0. Now what is the final angle? 180. Semicircle from 0 to 180. So here angles are taken from 0 to 180. So 180 means I am taking pi. 180 means pi. Integral 0 to pi. So 0 means the initial angle 0. 0 to now the final angle is pi. So here the dm. So initial angle and final angle. So 0 to pi. Now integral dE. So integral dE means e, and G cap m by pi r square into sin theta d theta minus cos theta. Integral sin theta d theta minus cos theta under the limits 0 to pi. Under the limits 0 to pi. Now we have, now E is equals to G. So minus equal right, go minus G m by pi r square of upper limit minus lower limit cos pi minus cos 0. Okay. Now E is equals to minus G m by pi r square of, so cos pi minus 1 and minus of minus cos 0 minus 1. So minus 1 minus 2, therefore minus gm by r square minus 2. So minus plus, minus into minus plus, therefore 2gm by r square. So this is the gravitational field intensity at the center of the ring. Gravitational field intensity at the center of the ring. So you can observe carefully here. So dE is taken as dE sin theta. Because of dE sin theta, so there is no dE cos theta. Because of everywhere we can take here dE is resolved into two components. One is dE cos theta and vertical dE sin theta. dE cos theta, dE sin theta. You can take here small m. So dE cos theta, dE sin theta. So dE cos theta and this side dE cos theta, both are gets cancelled. We have only sin components. That's why I am taking here. So dE sin theta. అందుకనే మనం ఏం రాసుకున్నాం, dE is equal to dE sin theta. So this is the entire value of dE into sin theta. Now integrating on both sides. The limits ఎక్కడ నుంచి తీసుకుంటాం, 0 dE ఇక్కడ ఉంటుంది, 0 నుంచి ఎట్లా వస్తుంది, 180, 0 to 180 లిమిట్స్ ఇక్కడ తీసుకోవాలి. నా ఇక్కడ మాస్ మనం dm స్మాల్ m తీసుకున్నాం కాబట్టి, సో ఈ స్మాల్ m ఎంత యాంగిల్ చేస్తుంది, d theta. స్మాల్ m makes angle d theta. Now here x ఎట్లా వస్తుంది, మనం x is equals to angle is equals to arc by radius. X is arc, angle is equal to arc by radius. Now x is equal to r d theta. So this entire value here, small mass, this entire value is taken as r d theta. అది వచ్చింది. సో ఇక్కడ అట్లా రాసిన మాస్ పర్ యూనిట్ లెంత్ is equals to dm per unit length. So this is the unit length for dm. Now dm value substitution and simplifying both sides by applying the limits, we get the resultant equation. Okay. Yes, I hope you understood well. Okay, note చేసుకోండి. సో ఇలాంటి మరిన్ని వీడియోస్ చేయడానికి, సో మంచి వీడియోస్ అండ్ జేఈ పాయింట్ ఆఫ్ వ్యూలో, మెయిన్స్ పాయింట్ ఆఫ్ వ్యూలో, నీట్ పాయింట్ ఆఫ్ వ్యూలో ఇంకా మంచి ఇన్ఫర్మేషన్ అండ్ సో ఇలాంటి ఇన్ఫర్మేషన్ కోసం సబ్స్క్రైబ్ చేయండి ఛానల్ని. సో మీకు నచ్చితే సబ్స్క్రైబ్ చేయండి, మంచి ఇన్ఫర్మేషన్ అండ్ సో ఖచ్చితంగా సీట్ కొట్టడానికి నా ఎఫర్ట్ నేను చేస్తాను. సో ప్లీజ్ సబ్స్క్రైబ్ మై ఛానల్. ఓకే, థ్యాంక్ యూ.